In 2007, astronomers discovered that potent, ultra-short radio signals were attacking Earth from all sides. These fast radio bursts last only a millisecond, but carry as much energy as the sun emits in 3 days. Some scientists linked those mysterious bursts to magnetars, the most powerful and dangerous magnets in the universe. Their impact on Earth can be felt even from thousands of light years away. In this video, you'll find out how can a crack on a magnetar cause a mass extinction on Earth? Why is it necessary to fire a star cannon to form such an object? And what will happen to us if we get close to a magnetar? How extreme are magnetars, and what are their properties in general? Massachusetts Institute of Technology engineers created the strongest superconducting magnet on Earth. Its magnetic field reached 20 Tesla. And no, this has nothing to do with Elon Musk. It means that the magnetic field created by MIT is 500,000 times more powerful than the field of Earth itself. It's dangerous for people to just be around this device, as the nervous system, heart, and other organs may just stop functioning. But at least we know the exact location of this magnet, while with magnetars, it's a bit more complicated. This exotic star can't be seen in the night sky, but its rays may find you nonetheless. In 1979, NASA and USSR spacecraft detected a powerful burst of gamma rays from deep space. Astronomers quickly found its source. The object is hiding somewhere here in the nebula N49. At first, astronomers thought it was an ordinary neutron star left after a supernova explosion. An ordinary neutron star is an incredibly dense object with a diameter of up to 20 kilometers and a mass of 1.5 of our suns and a very strong magnetic field, 100 billion Tesla. So if you compare that to your fridge magnet, it's about as powerful as the extinct giant shark megalodon is compared to a single atom. But once physicists calculated the exact parameters of the magnetic field of the neutron star from N49, they were amazed. The mark it reached was 1,000 times greater, 100 trillion Tesla. Comparing that to the magnetic field of an ordinary neutron star, it's as powerful as a neutron star itself is to a megalodon shark. Astronomers named the exotic object a magnetar. It rotates rapidly with a period of 2 to 10 seconds. At the same time, an incredibly powerful magnetic field heats it up to 18 million degrees Celsius. This is hotter than the core of our sun. However, the magnetar doesn't glow. It can only radiate X-rays and gamma rays here and now. So far, we've observed the most powerful magnets in the universe from afar, but could one of them suddenly appear somewhere nearby? For this, we need to understand how exactly magnetars are formed, and here astronomers have a huge problem. Logically, we get that an abnormally magnetic neutron star should form after an explosion of a massive supernova star with an unusually strong magnetic field, like this blue giant Theta 1 Orionis C. It's part of the star cluster that looks back at you from the bright Orion Nebula, just below the belt of the Orion constellation. Theta 1 Orionis C weighs as much as 40 suns, but its magnetic field is 1,000 times stronger. One day, this giant will explode and might leave behind a highly magnetized neutron star. Nevertheless, some scientists aren't convinced that this is enough, and the birth of a magnetar monster requires not one, but 2 stars at once. In the Westerland 1 cluster, 12,000 light-years away from Earth, astronomers discovered a mysterious magnetar that radiates X-rays through space. According to all calculations, a black hole should have been formed after the supernova explosion. But later, scientists realized that this place used to be a binary star system. The predecessor of the magnetar was draining plasma from its partner for millions of years. Thus, the friction of ionized particles charged its magnetic field. The supernova explosion afterward pushed the second star away with great force, which is essentially like a star cannon shot. So only the magnetar was left. According to scientists, some collisions of neutron stars can also lead to the formation of such exotic objects. Luckily for us, in the radius of 1,000 light-years around Earth, there are no magnetized blue giants or exotic binary stars ready to collide. Though, in fact, magnetars don't need to be close to harm the Earth. How are the most powerful magnets in the universe affecting us right now? Thank goodness, the fast radio bursts I referred to at the beginning affect you no more than a switched-on smartphone would from the moon. But sometimes, something can happen on the magnetar that can damage Earth even thousands of light-years away. In 2004, a sudden gamma burst blinded several satellites and made the Earth's magnetic field contract almost like during a solar storm. And this happened because of a magnetar on the other side of our galactic disk, 50,000 light-years away. If we could see gamma rays, the flash in the sky of 2004 would look like this. According to astrophysicists, it was caused by a powerful starquake. Due to the rapid rotation and fluctuations of the magnetic field, the incredibly dense neutron crust of the magnetar vibrated and shifted. You wouldn't even notice this crack, as it was 50 times thinner than a human hair. However, this tiny starquake unleashed tremendous energy. A flash with a duration of only 1/10 of a second was equal in power to the energy emitted by our sun over a period of 150,000 years. We're lucky enough to be far away from this magnetar, but who says it will always be like this? What will happen when the most powerful magnet in the universe gets closer to us, or we get closer to it? If supernova explosions launch stars as if from a cannon, they could also strike us with a magnetar's blast. If the same gamma burst as in 2004 strikes us from a distance of not 50, but 10,000 light-years, it'll be a catastrophe. Earth's weak magnetic field won't be able to resist the blow. It'll blow off the ozone layer and irradiate everything, leading to mass extinction. If a magnetar strikes us from a distance of 10 light-years, which is a little further than Sirius, Earth will be totally destroyed. Earth will literally roast in gamma rays and become similar to Mars. Hypothetically, a stray magnetar could even fly into our solar system. In this case, a burst isn't even needed. First things first, the massive object will take all the planets away from the sun. Then, as it passes near the moon, its magnetic field will shut down all electronics on our planet and wipe out data on all our hard drives. If we try to send a team of brave astronauts in advance in order to try to stop this monster somehow, at a distance of 1,000 kilometers, their bodies and any other objects will just disintegrate. A powerful magnetic field will rip electrons out of atoms and turn matter into dust. Luckily, no one will feel any pain, as the signals of our nervous systems will be cut off long before we get closer to the magnetar. Long story short, you'd prefer an encounter with a more harmless black hole than with the most powerful magnet in the universe. Lucky for us, as of 2022, we've only found 31 magnetars in space. There are so few of them because strong magnetic fields can't exist for more than 10,000 years and tend to gradually weaken. And this makes magnetars extremely rare, or I would even say quite precious. Do you remember that super strong magnet from MIT? It's actually designed for new generation nuclear reactors. So who knows, maybe our distant descendants will search for magnetars in order to build super powerful space-scale reactors. After all, we can benefit from even the most destructive powers in the universe.
May the Force be with you.